Hey everybody! So this lesson, lesson 4, solve percent problems with proportions. This is probably the most commonly used application of proportions is looking at percentages, finding tax and tip and discounts and that kind of thing. We're also going to be covering percent of change, which is becoming more and more common. I hear it a lot in the news. I hear it sometimes in advertisements, so it's good to know how it works. If you don't know how to convert between percentages, decimals, and fractions, that's what's in this top chart here. Okay, but the long and short of it is, if you have 50%, that means 50 per 100. Okay, and then you can just divide in a calculator to turn this into a percent. The calculator will spit out 0.5. But the other way you can think of it is that in the percent, this is the tenths, and this is the hundredths place. All right, I'm going to solve some of these using the proportion, part over whole equals percent over 100, or you can use the equation, which is the part is equal to the whole times the percent written as a decimal. Okay, so right here, this should say the percent as a decimal. And then a really important understanding that I don't think I really thought about until now is that when you go to a restaurant or somewhere else where you would leave a tip, like an Uber ride or something like that, you shouldn't have to pay a tip on the tax. Okay. So here is a word problem. It says, Ken, Mike, and Ariel are eating out at their favorite restaurant. They each order a sandwich combo and plan to split the bill evenly. The service they receive at the restaurant is amazing, so they decide to leave a 30% tip. 20% is a really good tip, so this is like a very good tip. Their bill total is $50.88 before tax. Okay. Florida sales tax is 6%. How much will each person pay? Both tip and tax are calculated based on the original total of the bill. Okay, so basically what I need to do here is I need to find 30% of the bill, the $50.88. And then I also need to find 6% of the 50.88. Okay, and then if I add these together, I'll get the total. But then I also have to add the original bill, so it's not exactly the total. Sorry. Oh dear. Okay, let me put that. Let's put this idea of adding it together aside for just a moment. Okay, and we'll find these percentages first. So I'm going to go ahead and use the equation. 30% written as a decimal would be 0.3. Okay, it might help you to think about moving the decimal 2 places to the left. Okay, so like 6% will be 0.06. Okay, 6 per 100, right? That's little. Okay, so we're going to multiply that by the 50.88. I'm going to do that in a calculator. 0.3, oops, 0.3 times 50.88. And I'm getting this number, which I'm going to round to the nearest cent. So 15.26. This is the tip. Okay, let's do the same thing for the tax. 5088 times 0.06. I'm getting this number, which is pretty small, but 6% should be small. So $3.05 if I round that off to the nearest hundredth. This is tax. Okay, and again, so this was 0.06 times 50.88. Okay, now let's talk about this. So we've got to find the total, and then we're going to share the bill with them. Okay, and we'll figure out how many people. It looks like 1, 2, 3 people are sharing this bill. So let's talk about the total bill. We're going to pay for the food. That's the 50.88. And we're going to pay the tip. That's 15.26. And we're going to pay for the tax. 3.05. Okay, so I'm going to add those all together, find the total, and then I'll divide by 3. 50.88 plus 15.26 plus 3.05. So I'm getting this number, 69.19. Okay, and now because they are sharing this, they are going to split the bill evenly. I'm going to divide by 3 and hope I get 23.06. So let's see here. Divide by 3. Yeah, I did. Yay. 23.06, and then there's 3 repeating, but I'm going to round that off to the nearest hundredth. $23.06 each. So big ideas here. I use the percent equation, turn the percent into a decimal, and then you're going to multiply. Okay, the bill times the tip percentage, and then the bill times the tax percentage. Okay, let's talk about percent error. Or what is this? No, it's not percent error. That's coming up. Percent of change. Okay, so the percent of change is if we put a percent on how big of a change that happened. Okay, if somebody told you there was 100% change, that basically means it doubled in value. Okay, if it's a 50% change, that means half of the original value added onto it. Okay, and this is something that I'm starting to see more of in like sale amounts, when they're saying that's a 100% change. So we've got your textbooks way, what's in your lessons. This is the hard way, and then this is the way I think of it. This is the easier way. Okay, so the hard way is this formula. It's got absolute value in it. Remember that absolute value just makes everything positive. The absolute value of -3 is +3. The absolute value of +3 is still +3. It makes everything positive. Okay, but what you can think about just is if you get a negative number, that's a decrease. If you get a positive number, that's an increase. Okay, then you don't have to mess with the absolute value. But the idea of percent of change, the relative change between the old value and the new value, expressed as a percentage of the old value. Okay, and then percent error actually works the same way. So I lied. We are going to talk about percent error. So basically what we're doing is we're putting a percent to how big of a change was it? How big of a change was it? Was it a 200% change? Oh, that's the one that doubled. 100% doesn't double it. It's a 200% change that doubles it. Sorry, guys. Okay, so this is one of your quick check problems. It's item 3. It says a university football stadium has 81,500 seats. The stadium is full at its full capacity on game day. And then Layla believes only 79,000 seats are occupied. That's her guess. Find the percent of error in Layla's prediction. Okay, or the percent of change. What's the change between what she thought and what it actually is? Okay, so what we're going to do here, we're going to do new minus old over old. Okay, so the new number is the 81,500 in Layla's prediction. Okay, that's her new number because she thought it was 79,000. So originally she thought it was 79,000. Now she knows it's 81,500. That makes the 81,500 the new amount. Okay, and then what we can do here is subtract. I can use a calculator, that's fine. Okay, 81,500 minus 79,000 equals 2,500. So that's how big her mistake was. She was off by 2,500. Okay, that's my new numerator. Move myself over here. Now I'm going to divide. Numerator divided by denominator. 2,500 divided by 79,000. So I'm getting this number, okay, and it says round to the nearest hundredth. Okay, so let's talk a teeny bit about rounding. So this number is about 0.031. When I round, I'm going to identify the place that I want to round to. That's the hundredths place. Then I'm going to look next door. If it's 5 or more, I'm going to raise the score. If it's less than 5, I'm going to let it rest at the 0.03. Okay, so answer is 0.03. Oh, nearest hundredth of a percent. That's just the 10th of a percent. Man, I'm going to need more of these numbers, guys. I thought we were rounding the decimal to the nearest hundredth. We're rounding the percent to the nearest hundredth of a percent. That's very precise. All for Layla. Okay, so let me take a few more of these numbers. Okay, so it was 0.03164. Okay, if I want, so let me show you where the percent is. Okay, so the percent is the 3 right here. Okay, the 10th of the percent is the 1, and the 100th of the percent is the 6. Okay, if I look next door, the 4 is telling me to let it rest at 6. I'm not going to round up. So my answer here will be 0.0316. And that is not one of my choices. So I got to figure out what I did wrong. And I'm really tempted to re-record this, but let me just see. If I move this green line, will it be correct? I hope. Okay, so they say the answer is 3.07. That means I did something wrong here. Let me see if I can spot any kind of error really fast. I'm going to look and see if I copied it correctly. 81500 minus 79000. And then subtract those, I get 2,500. Let me just redo the division. Minus, okay, and divide by 79000. I don't know. I don't see an error. Did I copy it correctly? It must be in the rounding, maybe. But I don't see how I would get a 0 there. Or the 7. I don't know, guys. That's what I'm getting. I don't know. We might have to just declare this close enough. And I might ask Miss Angel about it. Okay. But anyway, the big idea here, new minus old divided by old. Okay. Okay.